The best way to choose the number of components for a principal component regression is through cross-validation. You may have talked about cross-validation before, but it's important, and we're going to go through it completely right now. To illustrate this, I want you to think about this purple rectangle here as being your data. You have many observations. Now, I'm going to make 7 copies of your data. This is not something I'm actually suggesting you do as a first step to cross-validation. It's only for the purposes of illustration. You don't actually have to hold 7 copies of your data. Now, I'm going to divide each of these 7 copies into 7 pieces. What I'm doing here is 7-fold cross-validation. We generally think about cross-validation as being a set of folds. K-fold cross-validation involves K copies of your data divided into K pieces. And we go through K, which here is 7 rounds of validation. In each round, we are going to highlight one of these blocks of our data and use the 6 white blocks of data here for training the model, and that one purple block will be used to test the model. And we're going to record some kind of performance statistic here, like the mean squared error, or the R-squared, or the adjusted R-squared, or the C-statistic from logistic regression, or accuracy from logistic regression. Whatever it is, however you intend to measure your model on test data eventually, we're going to use that here to judge our model on each validation block. So we repeat that with the next block of data, and in the next block, I get a mean squared error of 0.2 on the purple block of validation data. At completion, I will have a mean squared error for each section of my data. In a sense, cross-validation lets you use your entire training set as validation. While you're not training on the entire training set at each round, you do overall use every observation as part of training, and you get a validation result on every observation in your data. So at completion, we would just look at like the average performance statistic for the model. Here, in the 7 rounds, my average MSE was 0.17. And I'd repeat this process, training our different models using 1 principal component, 2 principal components, 3, up to R. So in this example, each of our R models would be trained and tested 7 different times, 1 at each cross-validation iteration. So what we just looked at here is an iteration of cross-validation. So I would do this for the model with 1 principal component. I would do it for the model with 2 principal components, and 3, and 4. And so I would have this average number for the model with 1 principal component, for the model with 2, 3, 4. And that would allow me to choose the model that's best on validation data. So we're going to get in and apply principal component regression to some data first in SAS.